Welcome to 5.1 Trigonometric Identities, Example 2. If cosecant theta equals -5/2 and cosine of theta is less than 0, find all of the other trigonometric function values. I like to write out all of the trigonometric functions. I have written the three basic trigonometric functions on the left, sine theta, cosine theta, and tangent theta, and their corresponding reciprocal functions on the right. Since we know cosecant of theta equals -5/2, we can easily find sine theta by taking the reciprocal of -5/2. Therefore, sine theta equals -2/5. Now that we know that both sine theta and cosine theta are both negative, we know that theta must be in quadrant 3. Now I can record that sine theta is -2/5, and we also know that cosecant theta is -5/2. Because we have sine theta, we can use the Pythagorean identity to find cosine theta. If we use sine squared theta plus cosine squared theta equals 1, we can plug in -2/5 for sine of theta. -2/5 squared plus cosine squared theta equals 1. First we simplify by squaring -2/5. We get 4/25 plus cosine squared theta equals 1. Now we will subtract 4/25 from both sides. Recall we can write 1 as 25/25 and then subtract. Thus we get cosine squared theta equals 21/25. To get rid of the square, we square root both sides, not forgetting about the plus or minus. Because we are told that cosine is less than 0, we choose the negative square root. To simplify the square root of 21 over 25, we simply take the square root of 21 over the square root of 25. So cosine of theta will be -rad 21 over 5. Since we know cosine of theta is -rad 21 over 5, we know that the secant of theta is a reciprocal. So secant of theta is -5 over rad 21. Multiplying the numerator and the denominator by rad 21, we get secant of theta equals -5 rad 21 over 21. Now we are ready to move on to tangent. Using the quotient identity, we have tangent of theta equals sine theta over cosine theta. We have already found sine theta and cosine theta, so now we simply plug in the values and simplify. Sine theta is -2/5, whereas cosine theta is -rad 21 over 5. The negatives cancel and the 5's in the denominators cancel, so we get tangent is 2 over rad 21. Rationalizing the denominator, we will get 2 rad 21 over 21. Lastly, we need to find cotangent of theta, which is the reciprocal of tangent of theta. For ease, let's flip 2 over rad 21. Therefore, cotangent of theta is rad 21 over 2. As a final check, I like to make sure that our answers are consistent. Since we are in quadrant 3, we would expect sine and cosine and their reciprocal functions to be negative, and we expect tangent and its reciprocal to be positive, which is consistent. I hope you enjoyed this video.